Today's topic is the binomial theorem. Very famous theorem. It's much more complicated than what we'll get into, although we're not going to get into the more complicated parts. And then we start off by saying, recall, what is a plus b squared? It's a squared plus 2ab plus b squared. Do you remember that? Now, what's a plus b cubed? Well, we can think of that as a squared plus 2ab plus b squared, which is a plus b squared times a plus b to the first power. So in distributing this, you can distribute it a couple different ways. I like taking this and multiplying it by all three. 2a squared b, and then we have ab squared, and then we go to the b's, we have a squared b, 2ab squared, b cubed. Combining like terms, you get a cubed. 3a squared b, 3ab squared, b cubed. Now, if we were to do a plus b to the fourth, maybe we could multiply this times itself, and then a plus b to the fifth, we could do this times itself, and then tack on that. That would be it's a cumbersome process. And the binomial theorem helps out with this, with using this thing. And you may recognize this is Pascal's triangle. And each element of Pascal's triangle is formed by adding the two numbers that are, say, diagonally above them. Like, say, this 2 is formed by adding the 1 and 1, this 4 by the 1 and the 3. Now, there's really no way of doing that for the first two rows, but so that it's defined as, and these are the rows. So that's row 0, and then the, 1, 2, 3, 4, 5. And these are diagonals. It's diagonal 0, 1, 2, 3, 4. Obviously, this thing continues. All right. And each individual element can be formed by using Pascal's triangle, but they're also related to combinations. And you've probably seen this before. This element right here it's the combination of 5 things, 2 at a time. We say combination of 5 things, 2 at a time. What does that mean? Say you got a group of 5 things. You can pick 2 of them at a time, like group A, B, C, D, E. Well, AB would be a group of that, but BA is not a different group. BA and AB are considered to be the same group. Now, that's different than permutations. All right, so the combination of 5 things, 2 at a time, and I'm not going to get into that too much, is 10, and the combination of 5 things, 3 at a time, is also 10, because that's in the same diagonal. Now, it's worth noting this, some books use a little bit different terminology. They'll use this terminology, and you'll probably see this when we say 5 choose 2 or 5 choose 3. It's the same thing. Our calculators use the combination terminology, and the way you do it is you have to put the first number, the 5, in first, and then go to the math menu and to probability, and then your choices are there. This choice 3. Okay, and similarly, what you're going to find with Pascal's triangle and with combinations is each of these rows has a symmetric look to it. The numbers go up, they come back down with the exact same numbers. Now, the odd number rows actually have an even number of elements in them. They'll have, row 5 has 6, so these two numbers in the middle will match one another. The even number rows have an odd number of elements. The one in the middle is unique to that row, and it'll be the highest number in that row. All right, now this is used for the binomial theorem, and the theorem says if you take, say, a plus b to the nth power, and it doesn't have to be integer power, and we're not going to talk about non-integer powers, but if you do some research on this, there's a lot more to it than what we're going into here, and it's I mean, I've done this research, and it's interesting stuff. It's difficult to grasp. So if any of you are interested in it, you can do it. Yeah, you know, I don't know what if people are going out on tangents, as I've suggested in a couple of these videos. I don't really know if you're doing that or not. I'm suspecting not, because I haven't gotten any of the bonus questions back. I guess if it doesn't mean anything, you don't do it. Is that right? All right, well, this is going to end up being the combination, and it always starts with this, is n things 0 at a time. The first element in every row is always going to be 1, and this combination is always 1, and that's going to end up with a to the n and then b to the 0. Now, the next thing is n things 1 at a time, and that's going to be right here. And the combination of n things 1 at a time is n, and that's always going to be the case. Say, for example, and I'll put this over here. Let's say we have a group of 4 things, A, B, C, and D. Going back to n things 0, how many ways are there of choosing 0 of these? There's only one way to choose 0, and that's not choosing anything. I say, okay, how many ways can I choose nothing? Well, there's only one way of doing that. Now, contrast that with how many ways can I choose one of them? Well, a combination of n things, or this would be 4 things 1 at a time. You can have A, you could have B, you could have C, or you can have D. There are 4 ways of doing that. All right. And that's going to end up being multiplied by A to the n minus 1. This power will decrease, and B will go up. Now, there'll be any number of terms between, and the second to the last term is n minus 1. And that'll be raised A to the 1, B to the n minus 1. These numbers always match. And you know, this combination and this combination are going to be the same number. And here's the example over here. What's the combination of 4 things 3 at a time? What way can that happen? Well, what ways of groupings of this? Well, there's A, B, C. There's A, B, D, systematically going about this. A, C, D, and B, C, D. There are 4 ways of grouping these 3 letters. Now, keep in mind that we're talking about combinations here, not permutations. Because if we were talking about permutations, B, C, A would be different than this, but it's not. But for combinations, it's not different. All right, and then the last term in the binomial theorem, combination of n things n at a time, a to the 0, b to the n. Now, combination of n is going to be a 1, always a 1 on the last term. All right, well, how does this work? Let's see, let me find my example so I don't screw this up. I like to do an example that's got all of the the complications in it. All right, here we go. (2x minus 3y), and this will be more complicated than anything you do tonight. All right, and it's only because of the negative sign in this additional. Let's do. The additional y variable in here and so forth. And we can even make it a little bit harder by doing something like this, 2x squared and 3x to the third. Okay. All right, well, following along. Okay, so this is going to be out of row 4, so we're going to look at these numbers in here. All right, so this is the combination. I'll write this whole thing out of 4 things 0 at a time, and then this is going to be 2x to the second to the 4th power, followed by negative 3y, and be careful about this negative sign, to the 0. Combination of 4 things 1 at a time. 2x to the second to the 3, negative 3y to the third to the 1. Combination of 4 things 2 at a time. 2x to the second to the 2, negative 3y to the third to the 2. Combination 4 things 3 at a time. 2x to the second to the 1, negative 3y to the third to the 3. And 4 things 4 at a time. Running out of space here. I'll make it though. 2x to the second to the 0, negative 3y to the third to the 4. Now, a lot of this stuff we're going to know. this is going to simplify quite a bit. This number is a 1, and I'll write these out. All right, now this is going to be 2 to the 4 times x to the second to the 4. This, anything to the 0 power is 1. 4 things one at a time, that's that 4. Remember, it's always going to be, with this, it's going to be that number. Okay, so this is 4 times 2x to the second, or writing it out, 2 to the 3, x to the second to the 3, times negative 3 to the 1, times y to the 3 to the 1. 4 things 2 at a time, there's a 6. Okay, keep going with the pattern here. 2 to the second, x to the second to the second, negative 3 to the second, and you got to be careful with that. Y to the 3 to the second. I'm trying to squeeze this a little bit because I'm going to run out of space. This is a 4. I should put this in the parentheses. 2 to the 1, x to the second to the 1, negative 3 to the 3, y to the 3 to the 3, 1. That is 1. And then we have negative 3 to the 4, and y to the 3 to the 4. Made it. Okay. So now we got 1 times 16 x to the 8th. All right. Then I'm going to have 4 times 8 times negative 3. 4 times 8, because there's negative 3 is the 1. 4 times 8 to the 3 is the 8. So that's going to end up being negative 96. Now the powers, this is x to the 6th, y to the 3. All right. Now we're going to have 6 times 4 times positive 9. 6 times 4 times positive 9, that's 216. All right, and that's x to the 4th, because x to the second, and y to the 3rd to the 2 is going to give me y to the 6th. Okay, in this case, this one here, we're going to have 4 times 2 times negative 27. 4 times 2 times negative 27 is negative 216. This is going to be x to the 2 and y to the 9. And then finally, we got 1 times 1, and negative 3 to the 4th is a positive number. That's 81. We have no x's because it's x to the 0, and then y to the 3 to the 4, which is y to the 12. All right. Now that will be a little bit harder than anything that you have to do for homework, because we had, you know, the homework problems don't have all of these things. The negative sign is going to affect things in that, I mean, what you find out very quickly is that every other term is negative. And that happens because, you know, the first time through you raise the negative 3 to the even power of 0, and then the next term you raise the negative 3 to the odd power of 1, then the negative 3 gets raised to the even power, then the odd, then the even, and it's always going to alternate just like that. Because of the nature of these powers going from, you know, just following through the integer values. Okay. All right, so you're going to have to do a little bit of that. And there are also problems for the homework that are like this. Get in frame. Okay, let's take a look at number 48. And number 48 says, say we have x cubed minus y squared to the 24. Now you're not going to have to write that whole thing out. It says find the x to the 30 term. All right, now how are you going to get x to the 30? X to the 30 is formed by raising x to the 3 to the 10. All right, the x to the 30 term, x to the 3 to the 10 forms the x to the 30 term. All right, well then you're going to have a combination of 24 things, some number at a time, and you need this, x to the 3 to the 10, and then you're going to have negative y to the second to some other number. Now what are these numbers? Now if you recall back here, look at it, that these numbers always match. Oh, there's a mistake, actually. Go back and fix that if you were taking notes. That was 1, that wasn't that. Yeah. It's a good thing we went back and looked. This number and this number will always match. The power of the second part of the binomial theorem matches the number on the combination. Okay, so let me get back into the frame. All right, so we want the 10 here. Or no, we want the 14 here, I should say, because these two numbers have to add up to 24. So that puts the 14 right here. All right, I forgot to mention that. If this is x to the third to the 10, this number is going to be 14 because those two numbers have to add to 24. Now this number will match that one. Okay. So this is going to be the combination of 24 things, 14 at a time, and that number turns out to be 1,961,256. You can put commas in there if you want, and then we're going to have x to the 30 and y to the 28. You can leave this like so. I don't need that number. But if you look in the back of the book, I'll give you odd problems. You can look in the back of the book and make sure that you get the right number. You should check it definitely on your calculator. You know, calculate that number. Remember 24, then go to the math menu. It's actually easier going left on the arrows. One less keystroke. Then 14. Now let's say that, I mean, you could have done this and say, okay, this is going to be a combination of 24 things, 10 at a time. But that, even though you get the right number, because the 10 here, you're gonna get the right number. But it really, by the binomial theorem, this number should match that number. So when you write it out, you really should put the number here. I mean, but if you calculate it with a combination of 24 things, 10 at a time, you're gonna get the same number because, well, they have to be the same number by definition. Okay. All right, let's take a look at number 50. It's again, it's not as complicated as what we did is the example. Okay, 3x plus 2y to the 7. They say they want the y to the 4 term. Well, you get the y. There's no power here, so the y to the 4 term is raising this to the 4th power. All right, so again, we're going to have a combination of 7 things. So 4 at a time because we're raising the y term to the 4 power. And that's going to be 3x to some power and then 2y to the 4th. Now this is going to have to be 3 because those two numbers have to add up. All right, so that's going to be the combination of 7 things, 4 at a time, times 3 to the 3rd, times x to the 3rd, times 2 to the 4th, times y to the 4th. Okay, now, again, I mean, we can do this. Let's just go ahead and do it. All right, we're going to take the combination of 7 things, 4 at a time, and multiply that by 3 to the 3rd, and then multiply that by 2 to the 4th. And you get 15,120. And that is x to the 3rd, y to the 4th. All right. Well, then for homework, or for your assignment, I would say, theoretically, this is the last day that I can assign anything that can be possibly collected. And I do say possibly. All right, so okay, so we're in the same section. Of course, I don't have that written down. I think it's 15.3. It's the only section that has this type of stuff, so you figure that out. I don't have that with me here where I do my videos. All right, you do numbers 39, 47, and 49. Okay, and that's one of each type of example that we just went through. And pay attention to your negative signs and everything. Okay. Like I said, I think this is the last day for anything I might collect. I'll put a couple of videos up over the next few days. We'll talk about some concepts that might interest you. We'll see. And the way the school's saying that we can't assign anything that will be collected after today, I can't imagine anybody doing anything. But I'll continue to put something up because some of you may be interested in the topic, and we're going to talk about mathematical induction, which is a very interesting topic, and I know from years past a lot of people did have interest in it. But again, I think interest is waning at this point. So, all right, well, I will probably talk to you tomorrow.